Next, we are going to see the amplitude scaling. Consider a signal that is fed into an amplifier with a gain 3 dB. Then the output y of t is said to be 3 into the original signal, that is the x of t. Now here is an example for amplitude scaling. An original signal has been considered with an amplitude of 1 and time period from -1 to 1. Now the output for 2 into x of t, that is, it is scaled twice, so the output will be like this. The amplitude is now 2, but the time period does not change. I repeat, there is no change in the time, only the amplitude doubles. So this is y of t is equal to 2 into x of t. Whereas in the second output, we see you have to get -2x of t. So when we say -2, the amplitude is twice than the original signal but on the opposite direction. But the time period remains the same. It is again from -1 to 1. The amplitude is twice than the original signal but in opposite direction since we have a minus. Now it is y of t is equal to -2x of t. This is called amplitude scaling. I repeat, in amplitude scaling, the time period does not change, only the amplitude of the signal changes. When we say 2x of t, the amplitude becomes twice the original signal. Here it again becomes twice the original signal but in opposite direction since we have a minus sign in front of 2. Next is the signal addition for continuous time signal. Here we are going to consider two signal x1 of t and x2 of t. When you add the two signal, the new output is equal to x1 of t plus x2 of t. Now consider an original signal. There are two original signals. This is original signal 1, this is original signal 2. x1 of t, x2 of t. Here we see there are two different amplitudes and of two different time period. In the first signal, there is an amplitude of 1, whereas it starts from t is equal to -3, goes on till 3 is equal to 3. Whereas in the second signal, it starts from -5, goes on till 5 and the amplitude is 2. Now we are asked to add the two signals. Let's see what comes. Before starting, we have to see which signal has a higher time period and please note that down. Now if you see, the second signal has a higher time period. Note that down. So 0, 1, 2, 3, 4, 5. -1, -2, -3, -4 and -5. The second, check out the amplitude at each t. When t is equal to -5, please see the amplitudes of the two. When t is equal to -4, check the amplitude, add them and write. So let's start with -5. When t is equal to -5, let's see what the amplitude of the two signals are. Here at -5, the amplitude is 0. So 0 plus, here at -5 you have the amplitude of 2. So 0 plus 2, it will be 2. Amplitude 2. In the second point, so this is the starting point. At -4, you have 0 here. You have 0 plus again another 2. So 4 also, the amplitude of 4 is 2. Then let's check for -3. At -3, the amplitude is 1. Whereas here, the amplitude is 2. So 1 plus 2, we get it as 3. So for -3, the amplitude is 3. Then let's check for -2. It is again 1 plus 2. minus 3, sorry, plus 3. For minus 1, 1 plus 2, 3. At 0, it is 1 plus 2, 3. At 1, 1 plus 2, 3. At 2, 1 plus 2, 3. At 3, again 1 plus 2. So, we have found out so much. Let's check out for t is equal to 4. When t is equal to 4, it is 0 for the first signal, whereas it is 2. So, 0 plus 2, again it will fall down to your 2. For 5, it is again 0 plus 2, it is 2. So, finally, this is the output signal y of t. Okay, the amplitudes of both the signal are added and placed in the correspondent t value. When t is equal to minus 5, what is it? Minus 4, what is it? When it is minus 3, it is 3. And when it's 3, again 3. The rest, you know. Next, we are going to see signal subtraction for continuous time signal. Here, two signals are considered, x1 of t and x2 of t. x2 of t is subtracted from x1 of t. There are two signals, both are the original signals, x1 of t and x2 of t. We are going to subtract the second signal from the first signal. In order to do so, see the time and write whichever has the maximum time period. So here we see the second signal has the maximum time period. So please note that in the resulting signal, that is y of t. So 0, 1, 2, 3, 4, 5. Minus 1, minus 2, minus 3, minus 4, minus 5. 1, 2, minus 1, minus 2. Next, when t is equal to minus 5, at t is equal to minus 5, check the amplitude of the two. The amplitude at minus 5 here is 2, whereas here it is 0. So this becomes x1 minus x2. So 0 minus 2, which is nothing but minus 2. At minus 5. So this is the first amplitude. The second, at minus 4. At t is equal to minus 4. See the amplitude, minus 4, it is again 0, whereas here it is 2. So 0 minus 2 will give you minus 2. So the amplitude is minus 2. Then comes minus 3. The amplitude of minus 3 is 1, whereas the amplitude of minus 3 in your second signal is 2. So at t is equal to minus 3, it is 1 minus 2 is equal to minus 1. And again for when t is equal to minus 2, it is 1 minus 1. When t is equal to minus 1, it is 1, again 1, 1, 1. And for 4, see when t is equal to 4. At 4, here 0, here you have 2. So 0 minus 2. Minus 2. 2. And for 5 again 2. So now you can draw the signal. This is your obtained signal. I repeat, two signal x1 of t and x2 of t are taken. x2 of t is subtracted from x1 of t. So when two signals are considered, write the larger time period for the answer. So this is the larger time period that has been considered. Take the first t, that is t is equal to minus 5. At t is equal to minus 5, here it is 0. The amplitude is 0, whereas it is 2 here. So 0 minus 2 is minus 2. That is why the amplitude is 2, but in the opposite direction. It is 2. This point it is minus 2. When t is equal to minus 4, the amplitude is 0, whereas here the amplitude is 2. So again 0 minus 2 will give you another minus 2. When t is equal to minus 3, the amplitude is 1, whereas here the amplitude is again 2. So 1 minus 2 will give you minus 1. And this goes on for the rest of the sum. The last operation on continuous time signal is the signal multiplication. The multiplication of two signals can be obtained by multiplying the values at every instant. Here, take an example. x1 of t is the original signal, x2 of t is another original signal. Now we are going to multiply the two. So the resultant signal is going to be y of t is equal to x1 of t into x2 of t. So for that, again take the maximum time period and mark it at your y of t. So here we'll take from minus 6 to 6. So 1, 2, 3, 4, 5, 6. Minus 1, minus 2, minus 3, minus 4, minus 5, minus 6. Now let's start multiplying the amplitudes of the two signals. At t is equal to minus 6. At t is equal to minus 6, let's see what are the amplitudes are. Here it is 0. Whereas here it is 2. So 0 into 2. 0 into 2 will give you 0. So here it is 0. Next at minus 5, t is equal to minus 5. You have 0. Here you have 2. So again 0 into 2 will give you 0. So this point is again 0. For minus 4 also it will be 0. Let's consider t is equal to minus 3. Now at t is equal to minus 3, the amplitude is 1. Whereas here the amplitude is 2. So 1 into 2. 1 into 2 will give you 2. Next, t is equal to minus 2. At t is equal to minus 2, you have 1 here and you have 2 here. So 1 into 2. Again 2. At t is equal to minus 1, 1 into 2. At t is equal to 0, amplitude is 1 into 2. At t is equal to 1, 1 into 2. At t is equal to 2, again amplitude is 1, 2. 3, the same. Now, when it comes to t is equal to 4, see here, t is equal to 4, the amplitude is 0, whereas the amplitude is 2. So 0 into 2, that gives you 0. Okay, so final signal will be this is your final signal that has been obtained by multiplying x1 of t and x2 of t. I repeat, two signals are taken and you're multiplying to obtain the third, that is the y of t. Take the maximum time period and draw it for the output signal. Out of the two, minus 6 to 6 has the maximum time period, so please draw that. Once you're done with this, take for each instance, that is t is equal to minus 6. At t is equal to minus 6, see the amplitude, it is 0, whereas the amplitude is 2 here. So 0 into 2 will fetch you 0. At instance t is equal to minus 5, the amplitude is 0, here it is 2. So again 0 into 2, 0. It goes on and changes at t is equal to minus 3. When you say t is equal to minus 3, here the amplitude is 1, here the amplitude is 2. So 1 into 2, you will get it as 2. That is why we have drawn at 2. And similarly for the rest of the t's.